Welcome to Daikin web-based training. When a problem occurs in an air conditioner, a malfunction code will be displayed on the remote controller in order to communicate what the problem is to the user. When service persons come to repair the air conditioner, they can determine the specifics of the malfunction in question based on the malfunction code. This course will provide you with an opportunity to learn about how to diagnose the problem in the event an E4 or JC malfunction code appears. Let's go over what we will be learning in this course. First, we will look at in what situations the remote controller displays the E4 and JC malfunction codes. Next, we will look at low pressure control of the air conditioner in relation to the E4 and JC codes. After that, we will look at the causes of the E4 and JC codes. Finally, we will learn about the diagnostic methods used to rectify these malfunctions. An air conditioner uses the indoor unit's heat exchanger during cooling operation and the outdoor unit's heat exchanger during heating operation in order to absorb heat. This decreases the pressure in the heat exchanger. The pressure drops even more if the heat exchange in the heat exchanger does not proceed smoothly for some reason. Any abnormal drop in the low pressure activates the protective device to stop the air conditioner. E4 is the malfunction code displayed on the remote controller when the air conditioner is stopped upon activation of the protective device due to an abnormal drop in the low pressure side. JC is the malfunction code displayed when the air conditioner is stopped after the low pressure sensor detects an abnormal pressure value. Please note that in this course we will learn about the malfunction codes related to the low pressure protection and control of R410A air conditioners. If the E4 or JC code is displayed and the air conditioner stops as a result, the primary cause is a problem on the low pressure side in the air conditioner's refrigerant circuit. So, we will first look at low pressure control of an air conditioner. This is a close-up figure of the low pressure part of the air conditioner. The low pressure sensor can be found between the compressor's suction pipe and the evaporator. The low pressure sensor is used to prevent the low pressure from falling beyond a certain point by controlling the compressor capacity based on the low pressure value it detects constantly. The evaporator is a type of heat exchanger that superheats and vaporizes the low temperature, low pressure liquid refrigerant using air around the air conditioner. A cooling fan and fan motor constantly provide fresh air to superheat the low temperature liquid refrigerant. In the event of a problem with the above-mentioned functional components or faulty heat exchange, the low pressure falls abnormally, resulting in an abnormal shutdown due to the E4 or JC status. In the following topic, we will discuss the causes that lead to each of the malfunctions. Let's now go over the causes that lead to the E4 and JC codes. There are three primary causes that lead to the E4 and JC codes. The first is related to problems with the air conditioner's internal components. The second one has to do with cases when the passage of air through the evaporator is obstructed by an external factor. The third cause is a decrease in the air temperature at the evaporator inlet as a result of improper installation. We will take a closer look at these causes from the next page. Let's now take a look at the causes resulting in the E4 code. Among the causes that lead to the E4 code, let's first look at those related to the cooling fan. The fan in the evaporator is always on during heat exchange in order to deliver fresh air. If the air conditioner's fan or motor malfunctions, it fails to deliver the air necessary for this heat exchange process, causing a drop in the low pressure. This results in the E4 code. Damage to the fan blades also prevents the delivery of the air necessary for heat exchange, causing a drop in the low pressure and resulting in the E4 code. Let's now look at the causes related to the low pressure sensor. If there is a drop in the low pressure, the air conditioner first uses the low pressure sensor to increase it via the compressor capacity control. If the compressor capacity control cannot sufficiently control the drop in the low pressure, the air conditioner uses the low pressure sensor to turn itself off, and the E4 code is displayed on the remote controller. The E4 code is also displayed on the remote controller when there is a discrepancy with the pressure level detected by the low pressure sensor or a problem with the outdoor PCB. Let's now look at the causes related to an increase in the evaporation capacity. The primary cause is an insufficient refrigerant charge. The refrigerant charged into an air conditioner changes from liquid to gas, or in other words, evaporates, while maintaining a certain evaporation capacity in the evaporator at the design pressure. At this time, the amount of refrigerant flowing in the evaporator decreases, resulting in a lack of refrigerant and causing an increase in the evaporation capacity in the evaporator. Since there are no changes in the amount of gas sucked into the compressor, the airflow rate of the cooling fan, or the size of the evaporator outlet, an increase in the evaporation capacity while there is insufficient refrigerant in the evaporator causes a drop in the low pressure and results in the E4 code. Let's now look at the external factors affecting the evaporator. The fan in the evaporator is always on during heat exchange in order to deliver fresh air. Therefore, the longer it is used, the more dirt and dust collect on the aluminium fins on the heat exchanger. As this layer of dirt and dust gets thicker, it can clog the heat exchanger, which prevents the necessary amount of air for heat exchange from being delivered to the heat exchanger and causes a drop in the low pressure. This results in the E4 code. Even if the evaporator is not dirty, there may be cases when an obstruction, such as a plastic bag, has been blown onto the evaporator. This creates a condition similar to the aluminium fins on the heat exchanger being clogged, causing a drop in the low pressure and resulting in the E4 code. Let's now look at the causes related to the air conditioner installation. There is usually an 18 degree Fahrenheit difference in the temperature between the heat exchanger inlet and outlet, and cold air from the outlet side is discharged to the atmosphere. If the air conditioner is not installed in an appropriate location, however, it can cause a phenomenon called a short circuit, where the cold air discharged from the heat exchanger outlet is not properly released to the atmosphere, and directly returns to the heat exchanger inlet. When an air short circuit occurs, the cold air discharged from the heat exchanger outlet is once again sucked into the air conditioner. This creates an unwanted cycle where this cold air decreases the heat exchanger inlet temperature, which then decreases the outlet temperature, which then further decreases the inlet temperature, and so on. The drop in the inlet temperature also causes a drop in the low pressure, resulting in the E4 code. Let's now take a look at the causes resulting in the JC code. JC is the malfunction code displayed on the remote controller when there is a problem with the pressure sensor, or in other words, when the air conditioner malfunctions. The possible causes are a problem with the low pressure sensor itself, a loose connector between the low pressure sensor and the outdoor unit PCB, or a problem with the outdoor unit PCB. Let's now learn about the diagnosis of the air conditioner side. When the E4 malfunction code appears, the first step is to diagnose the air conditioner side, such as the fan, motor, low pressure sensor, and refrigerant circuit. The next step is to check whether there are any external factors affecting the evaporator that conducts heat exchange at a low pressure. The last step is the diagnosis of the air conditioner installation. Note that the JC code only requires the diagnosis of the pressure sensor and PCB. Let's now learn about how to check the air conditioner side. The E4 malfunction is caused by various problems with the low pressure part of the air conditioner, and we will look at them one by one. First, attach a gauge to the air conditioner while it is off, and check the pressure when it is off. In this state, measure the air temperature around the outdoor unit and obtain the current refrigerant pressure in the air conditioner using the refrigerant saturation curve. If the outdoor air temperature is 73.4 degrees Fahrenheit, the saturation curve tells you that the refrigerant pressure in the air conditioner is 217.5 psi. If the actual pressure of the air conditioner measured by the gauge is lower than the obtained refrigerant pressure, this may point to an insufficient refrigerant charge, or a refrigerant gas leak. Therefore, it is necessary to check the refrigerant circuit. If the pressure level obtained from the saturation curve is the same as that measured by the gauge, proceed to the next item to be checked. Let's now learn about how to check the operating pressure. First, turn on the air conditioner to check whether the compressor starts running. If it does, check the operating pressure. In order to do this, attach a pressure gauge to the service port on the air conditioner's low pressure side. The low pressure during cooling operation is usually 108.8 to 137.8 psi. If it drops lower than 49.3 psi, the air conditioner initiates low pressure control to increase the pressure. If it is the case, assume that the low pressure is dropping for some reason, and check the items on the next pages one by one in order to determine exactly why the low pressure control is activated. The first item to be checked when determining why the low pressure control was activated is the cooling fan. Check whether the cooling fan is operating properly. If not, check for any damage to the fan blades. If there is a problem, replace the fan. If not, check the coupling between the fan and fan motor shaft. After turning the air conditioner off, turn the fan by hand to confirm that it does not just spin freely. If the fan motor is completely broken down, a different malfunction code will be displayed. If the low pressure is low despite the fact that the fan has been confirmed to be operating normally, proceed to the next item to be checked. The next item to be checked is the low pressure sensor. The low pressure during operation is controlled by the low pressure sensor. If the pressure detected by the sensor differs from the actual pressure, the low pressure sensor fails to control the low pressure and results in the E4 code. The pressure detected by the low pressure sensor can be obtained using the graph or formula in the service manual, based on the DC voltage measured at the connector between the sensor and the PCB. To measure the DC voltage, first set the tester to the DC mode. Then, as shown in this photograph, place the tester's negative probe on the black wire and the positive probe on the white wire at the pressure sensor's connector. Either use the measured voltage, VL, in the formula, or locate it on the graph to obtain the pressure, PL, detected by the pressure sensor. Let's check the measured level using the graph. When the VL is 1.8 volts, the PL is read as 108.8 psi, and this tells us that the pressure detected by the low pressure sensor is 108.8 psi. When the VL is 1.0 volts, the PL is read as 42.1 psi, and this tells us that the pressure detected by the low pressure sensor is 42.1 psi. If there is a discrepancy between this detected pressure level and the actual pressure level measured by the pressure gauge, it indicates a false detection of the pressure level by the pressure sensor, and the sensor must be replaced. When the measured level on the gauge is 108.8 psi, for example, it corresponds with the pressure level detected by the pressure sensor when the VL is 1.8 volts. In other words, there is no problem with the pressure sensor, and you can proceed to the next item to be checked. When the VL is 1.0 volts, however, the level measured by the gauge and that detected by the pressure sensor do not correspond. This indicates a false detection of the pressure level by the pressure sensor, and the sensor must be replaced. The next item to be checked is the evaporator and its surroundings. Check to see if the evaporator is dirty or there is something obstructing it, and whether the amount of air necessary for heat exchange is sufficiently passing through. If the surface of the heat exchanger is clogged with a foreign object, dust or the like, the object must be removed or the heat exchanger must be cleaned. If the surface is not dirty and the inlet temperature is 68 degrees Fahrenheit or higher, measure the air temperatures on the inlet and outlet sides of the heat exchanger. If the temperature difference is 68 degrees Fahrenheit or more, it indicates that the interior of the heat exchanger has gotten dusty. If so, it is necessary to clean it. If the heat exchanger is not dirty, the next item to be checked will be whether there are any problems with the air conditioner installation. The next item to be checked is the air conditioner installation. An outdoor unit must be installed in a location where it does not directly take in any cold air discharged after heat exchange in the evaporator, or in other words, a location that will not cause an air short circuit. If the suction air temperature is low, check to confirm there is no short circuit. Also, check whether the outdoor unit is sucking in any cold air discharged after heat exchange in the evaporator of another outdoor unit. If any of these scenarios apply, it will be necessary to reinstall the outdoor unit in a different location. If there is not a problem with the installation, the only remaining cause of the E4 code is a problem with the refrigerant circuit, such as an insufficient refrigerant charge or clogged refrigerant piping, which will be the next item to be checked. Let's now learn about how to check the low pressure sensor. When the JC malfunction code appears, it may point to a faulty device peripheral to the low pressure sensor. First, check whether the low pressure sensor's connector on the PCB is properly connected. If it is, check the voltage output from the PCB in order to determine whether the PCB or sensor is faulty. In order to check the PCB voltage output, first set the tester to the DC mode. Then, as shown in this photograph, place the tester's negative probe on the black wire at the low pressure sensor's connector and the positive probe on the red wire. If the voltage is 5 volts, there is voltage output from the PCB. This indicates that there is no problem with the PCB. If there is no voltage reading, the PCB is faulty. Check the soldering on the back of the PCB. If there is no problem with the soldering, then the PCB must be replaced. If there is no problem with the PCB, check the low pressure sensor side. To measure the DC voltage, set the tester to the DC mode. And, as shown in this photograph, place the tester's negative probe on the black wire at the low pressure sensor's connector and the positive probe on the white wire. If the voltage reading ranges between 0.5 and 3.5 volts, there is no problem with the pressure sensor. If the voltage is lower than 0.5 volts or higher than 3.5 volts, there is a problem with the sensor's internal components and the sensor must be replaced. It should be noted that if the air conditioner is empty of refrigerant, this will also cause the voltage to fall below 0.5 volts. In this case, use the gauge to measure the actual pressure.